Can you just like stick with my answer later on in college?
Could we do what? What? Ask me again.
What if you did 174 minus 170?
Well, 174 minus 170 is going to give you a positive z-score.
Well, what if you just subtracted by 1?
Well, if you want to, but that's really the long. But if you recognize that you would have to do that, that's a long way around. You would only really want to use the symmetric part when you don't have to subtract from 1. You wouldn't want to use it to make you subtract from 1. You know what I'm saying?
Say you messed up with the formula.
Then, therefore, you could do the subtract from 1. Yeah. That's a good way to catch yourself. Okay, now, your z-score is negative 0.2. When you look this up, it's the 0, negative 0.2. And come over to the 0, 0. That's what you're looking up. So, what's the area for this guy? 4206? 4206. 007. I erased all my answers, so you're going to have to help me out. Okay, now does that make sense? Is it less than 50%? Yes, right? Now, if you're going to use your calculator, what you want to do is, this is your upper limit. Look where you're going from, your lower limit to your upper limit. Now, again, you're going to have to set this and use negative 999 as your lower limit. You'll never hit negative 999, and we don't want to. And my upper limit says stop at 170. Your mean is 174, and your standard deviation 20. And you'll get the same thing. This actually usually is more exact. We didn't have to round over here. It came to exactly negative 0.2. So you'll see it be exactly over here. If we round your z-score, then this one from your calculator is going to be slightly off. Like they're more exact because we have to round. But this one we didn't have to round. So you're going to see it to be the same thing. Okay? Now, yes, you still have to make a sketch. It allows you to bypass this z-score business. Okay, now 182. Somewhere over here is 182. And I want to the right. Is my area less than 50% or greater than 50%? Less. Is my z-score positive or negative?
Automatically, if you see like you got 0.7 and 0.6 on there, you know that's wrong.
Exactly. If you're right, because it would not make sense for your graph. Now, you're in the positive z-scores. That says subtract so that you get a positive number. If you forget what your z-score formula is, it's always x minus the mean. X minus the mean on the left-hand side yields you a negative. X minus the mean on the right-hand side yields you a positive. So we subtract these. Whoops. And what does this give us? 0.4. Thank you. So are we between 0 and 1? Yeah. Yes. Now, you have a couple of choices. You can look up the 0.4 on your chart, on your positive side, and you can come to the 0, 0, and you can use this answer, minus 1. 1 minus this answer. So what do I get when I look up 0.4? 6554? 4, thank you. Now, by the way, is that less than or more than 50%? More. So what does it tell me I have to do? 1 minus this. So you do 1 minus, and what'd you get now? 6, 4, 4, 3.
0.3.
Okay. Yes?
Isn't that? I thought it was. We did shade to the right.
Shade to the right. Shade to the right. It's a greater than. Now, what's another way to look this up so that you don't have to subtract?
Just
look up the negative. This is symmetric. So if I come over here and I look up this piece, shouldn't this area and this area be the same? All I care about is the area under the curve. That's my probability. So if I look up negative 0.4, I should get this answer. Okay. Now, if you use your calculator, you want from 182 on. That's your lower limit. And your upper limit 999. So if you want to do this, use your 182. That's your lower limit. Your upper limit, 999. Your mean, 174. Your standard deviation. Okay? And again, you have to go for decimal places. There's your 0.3446.
My lower is negative 999 and my upper is 182, and then I got the points, the other one, and then I started minus 1 from it, I got that.
You had to minus 1 from it,
Oh.
but because you're on the wrong side, you shaded to the left, not to the right. But I want you to make sure you follow your shading. Now, again, that's a good recover. That's a good recover because you looked at it and said it can't possibly be greater than 50%. I'll subtract from 1, which is what Damani had said too. If you make the mistake and you do it the wrong way, then you realize you can subtract from 1. You're using your properties for your standard curve and your normal curve combined. The fact that your area adds up to 1, the fact that your curve is symmetric, okay, the fact that it's symmetric about the mean, and we know that they're both equal to the left and the right of it, you're using all those properties to determine this, and that's good. Okay, let's have you guys try another one. All right, number 7. I want to see everybody work on number 7. X is the one in between. These set less than, less than. That's how your betweens always are set up. You want between 66 and 72. Now, you're going to find the Z for both of them, find the areas, and subtract your areas. You already did 66. Good. So we know the area for 66. All we have to do is find a z-square for 72. And we notice that 72 is going to be positive. So in between here. So that's going to be positive. And what's that z-square give us?
Negative 0.631.
Well, it's got to be positive.
For that one is just 0.1841.
0.184?
1.
0.181.
1841.
So we're going to round it to 0.84. Because you can only look up 2 decimals in your z-score. Did you get this?
What? 6.
Yeah, no, you
I got 0.896. I wrote it rounded to 0.9.
Okay. So, yeah, now be careful of this rounding. If your z-score is 0.89655 and you want 2 decimal places, this is going to a z-score of 0.90. Okay, now what's the area under the curve? 1841, that's what we're getting. Okay, so now,
8159.
it's got to be more than that though, because it's more than 50%.
It is? That little bit?
Well, to the left.
8,
It's your
1,
area
5, 9.
to the left. They do, but we didn't subtract yet. So what is that area? 0.8?
0.9 in here, so 0.8159.
Well, I'm depending on you guys, because I erased all my answers. Okay, and now you subtract.
Then once you get that answer, take 1 minus it.
No, you don't take 1 minus it. You just take the area in between. Okay, what'd you get when you subtract?
65%.
Give me the whole thing.
Oh, 0.6. I got a negative. 0.6849.
Okay,
Yeah.
always subtract the larger minus the smaller in your area. Guys, this is what your overlap does. Look up here a second. It's always the area to the left. Watch. Here's my area to the left of, just watch me, 0.90. This is my area to the left of this guy, negative 0.17. If I subtract this out, this goes away, and I am left with what's in between. Don't subtract that from 1. You want what's in between. Now, eyes up here a second. Look how close I am to the plus or minus 1. Plus or minus 1 on your empirical curve is about 68%. Shouldn't this be very close to 68%? So the plus or minus 1 in your empirical rule is 68.4. 68%. So if I'm close enough to that, then I know I got the in-between. The in-between is the tough one, but the in-between is the easiest one on your calculator because you've got a lower limit and you have an upper limit. So if you're putting it on your calculator, your lower limit is your 66. Your upper limit is your 72. So you don't have to have any negative 999. Wow. Oh, you see it? Okay, your mean and your standard deviation. Okay? Now remember, this is a good example of we rounded. We rounded. So therefore, theirs is a little bit more exact than ours is. We had to round both of our z-scores. And what happens is your calculator doesn't have to round. We had to round this z-score. We had to round the other z-score. But isn't it close enough?
So wait,
yes.
You have to round?
Well, when you look up your z-score table, you can only look up 2 decimals. So you have to round it to the hundredths place.
You have to?
Yeah, because how would you look it up?
Oh, I thought you
No, you have to look up your area. So once you find your z-score, yeah, round it so you can look up your table.
use the z-score to find the area. Okay.
Yeah, don't round your area. Your area is 4 decimal positions.
Alright.
But you have to round your z-score. Now, we also rounded our z-score here. We rounded twice. So we had a little bit of a rounding error where your calculator has no rounding error. So usually, like on a test or on a homework, I'll use the 2 answers. One that you get from the calculator, one that you get from doing out the formula. If we don't have to round, there is no difference. But because we had to round, there is a difference. Now the last part said the probability that x is greater than 72. Now we want this part right here. You already did 72. You found that z-score to be 0.9. You lift up that area to be this. Could that possibly be greater than 50%? So what do we have to do? Subtract it. You can look up the negative as well. Good, Nick. I could turn around and look up the negative 0.9 and not subtract it from 1. Or in this case, since I already know my area, I can just subtract my area from 1. Is this making a little bit more sense? Point 1841. Okay, now, let's interpret this. The probability of me choosing a person from this survey, this study, and that person being between 66 and 72 inches is about 68% chance that I'll pick somebody and they'll be between 66 and 72 inches. What's that?
Yeah, it's 69.49.
69.49?
Yeah.
Oh, okay, we were even closer. I'm going to have to be doing this myself instead of counting on you guys. But thanks for the heads up on that one. All right, are we good?
Yeah, but I'm hard to there's something else to say.
Part C is asked if it's unusual. So Dan, which one of these is an unusual probability?
C.
C? Why would you say C? It's 18%. What's our cutoff for being unusual?
2.
It's the plus or minus 2, which is 5%. Remember your book goes with the 5%. If it's less than 5%, it's unusual. So are any of these less than 5%?
No.
No, so they're not unusual.
The least usual would be A.
A would be the least likely to happen. Okay. Good. All right, let's see if we can take a look at another one here. Tomorrow you're going to have a quiz on this. Well, that was not here, but you're going to have a quiz on this tomorrow.
You won't be here?
And no, you're going to have a quiz on this tomorrow.
Isn't there a possibility of us?
What? No, not that I heard of.
Oh, that's yeah,
Okay, guys, let's walk through this together. Okay, this is a great situational problem for you guys to understand. This is how colleges look at these. These are your ACTs. In addition to SATs, you could take ACTs. Those are concentrated tests for each subject matter. And this is what a school is going to look at. They're going to pull out the mean of all the students that have taken it that year and the standard deviation. They're going to make a curve. They're going to know where your scores fall. So sometimes when they'll ask you, oh, could you take that test one more time, see if you get a little bit higher? It's because they need you to be in a certain percentile. Now, take your mean, put your mean across, and add 5.3 all the way down. Is this right? Okay, and then go back the other way. Somebody check my math. Okay, I want you guys doing this with me. Okay. Now, these are where your curves will, where your scores will stand. So when a college is looking at this, they don't want the scores down on the left side. They want the scores up on the right side. The third one. This one?
The third officer is 37.
Just 37? Okay, thank you. So they want the scores on the higher end. Most of your scores are going to sit right in here. So that's where the average amount of scores are going to come. They want the scores on the higher end. This is what they look at. Now, and I didn't really need to shade those in because we don't want to shade them in right now. So now let's set up your probability statement. Let's just at least get one of these. The probability that a score is less than 16. 16 is right over here. Okay.
16 minus 21 over 5.3.
Good. We know it has to be negative. We know that z-score is going to be slightly before the negative 1. Slightly before the negative 1.
Negative 0.96.
Negative 0.96. Thank you. And when I look at the area, it's the area to the left because this area is less than 50%.
0.968.
Thank you. So this tells me what is my probability of someone taking this test and having a score less than 16? About 16.85%. Okay? About, well, I like to use the decimals because it's really not 17. Probabilities and statistics, you really want to get a little bit more exact. So that's why we use their 4 and we just move it 2 decimals. So
What would you recommend moving forward? Like if we really had to make like a graph or like something like that?
Oh, then yeah, then you round it.
Then you round to the auto, like.
Yeah, then you use your rules of rounding. Okay. Is everybody comfortable doing this?
Yeah.
All right. Finish, guys. Finish this one for homework. Finish this for homework. We'll go over this one tomorrow, and then we'll take it home.
Good.
Okay.
Easy hot dog.
Yeah, that'll be a nice quiz. Some of you guys